Now let's solve question number 16. This is the first very short answer type question in section A. So the 16th question states, find the cofactors of all the elements of this given square matrix. So let's solve this question. Here, as it is a square matrix, for each and every element we will be obtaining the cofactor. So let's obtain the cofactor for the first element of the first row and first column. So this will be equal to minus 1 raised to the power 1 plus 1 into its cofactor. How do you obtain cofactors? So here, to obtain the cofactor of the first element belonging to the first row and first column, you eliminate the elements of the first column and first row. You are left with 3. So here you will be having 3. So this simplifies to the value 3. In similar manner, C1, 2, the cofactor of the element belonging to first row and second column, this will be given by minus 1 raised to the power 1 plus 2. And here, if you eliminate the elements of the first row and second column, you are left out with 4. So here we have 4. So this becomes minus 1 cube, that is minus 1 into 4 minus 4. Similar manner, C2, 1, this will be given by minus 1 raised to the power 2 plus 1, and here cofactor can be obtained by eliminating the elements of the second row and first column. You are left out with minus 2. So here this simplifies to the value 2. Moreover, the cofactor of element belonging to the second row and second column is given by minus 1 raised to the power 2 plus 2 into, we have here eliminated the elements of the second row and second column. You are left out here with 1. So this simplifies to the value 1. So here the required cofactors are 3, minus 4, 2 and 1. So this is the required answer for this question. ये चारों cofactor लिखने पे आपको मिलेंगे पूरे 1 number इस question के लिए. Now moving on to question number 17. Here we have question 17 which states, if f of x is equal to x into mod x for all x belonging to the set of real numbers, check its differentiability at x equal to 0. How do we check differentiability of a function at a given point? If its left hand derivative at that point is equal to the right hand derivative at that point, which is also equal to f of 0, then in that case it is definitely differentiable at that point. So here we have x equal to 0. So in this case, as f of x is equal to x into mod of x, at x equal to 0, you will definitely get here f of x equal to 0. So now let's obtain firstly left hand derivative. How do we get here left hand derivative? So for left hand derivative, you get that limit h tending to 0 of f of 0 minus h minus f of 0 upon minus h. That is required. So in this case, when we substitute f of 0 minus h in this given function, you are going to get minus h into mod of minus h. Minus f of 0, as I stated, 0 into mod of 0 is 0 itself. So here minus h will get cancelled and mod of minus h is h itself. So limit of h tending to 0 for h is equal to 0. So left hand derivative is equal to 0. Next, in similar manner, when we will try to obtain right hand derivative, it will be given by limit of h tending to 0, f of 0 plus h minus f of 0 whole upon h, where on simplification you will get that this is h into mod of h minus 0 upon h, where h gets cancelled and mod of h is h itself. So here limit of h tending to 0 is equal to 0. So we now clearly know that left hand derivative and right hand derivative both are equal at x equal to 0. That is making this point very clear that this given function f of x equal to x into mod of x is definitely differentiable at x equal to 0. So in this question, when you will first obtain this whole left hand derivative and after that you will obtain the right hand derivative. For this question you will get total 1 mark. And here in this step we are proving that this given function is differentiable at x equal to 0. So for firstly obtaining the left hand derivative and obtaining it as 0, you get half marks till this step. And next, when you obtain the right hand derivative and show that the given function is differentiable at x equal to 0, you get rest half mark. That gives you total 1 mark for this question. I hope it's clear. Now let's move to our question 18. Now let's take up question number 18. It states that find the value of sine inverse sine minus 17 pi by 8. So this is also a 1 marker question. And it's a very interesting question from the chapter of inverse trigonometric function. So very first, I write here, give an expression sine inverse sine of minus 17 pi by 8. as you are aware, sine of minus theta is equal to minus sine theta. So, taking that into consideration, I can write here sine minus theta is equal to minus sine theta. On applying this basic rule, we get here in the second step sine inverse minus sine 17 pi by 8, where 17 pi by 8 can be written as 16 pi plus pi by 8, where 16 pi can be further written as twice of 8 pi. So, it could be further simplified as 2 pi plus pi by 8. So, this again simplifies to the same value sine 2 pi plus pi by 8, that gives me 17 pi by 8, and you are aware that sine 2 pi plus theta is equal to sine theta. So, finally I will be getting here minus sine inverse sine pi by 8, and for all the values of x which is lying between minus pi by 2 to pi by 2, we get that sine inverse of sin x is equal to x for all x belonging to the set from minus pi by 2 to pi by 2. So, here using this very important rule, we get here that the value in this case will become equal to minus pi by 8. So, this gives me the required answer for this question. Here the value of this given expression sine inverse sine minus 17 pi by 8 is equal to minus pi by 8. So, in this question on answering this, you will get complete 1 mark for answering it right. I hope it is clear to you. Now, let's move to question number 19. Now, let's take up here question number 19. It states, find the value of integral of mod of x minus 5 where the limits are from 1 to 4. So, here in this question, very first I will consider I equal to this definite integral having limits 1 to 4 for mod of x minus 5 with respect to x. So, in this case, very first thing you need to do is eliminating this mod sign. For that, I will be checking up what will be the value of mod of x minus 5 within this given limit. So, here mod of x minus 5, if you consider any value between 1 to 4, let's consider here x as 1, you will be getting here 1 minus 5, that is mod of minus 4. So, what will be the resultant? Resultant will be 4 when you will eliminate this mod. Moreover, if you consider here the upper limit 4 as x, then 4 minus 5 will be also equal to minus 1. So, what will be the resultant? Resultant will be 1. That means here for all the values lying in this limit from 1 to 4, the value of mod of x minus 5 will be equal to minus of x minus 5 for all x belonging to this limit from 1 to 4. That means in this case we can eliminate this mod considering mod of x minus 5 as minus of x minus 5, which is 5 minus x. So, further I can write here that this integral I is equal to integral with limit 1 to 4, and here I am writing this as 5 minus x, which is minus of x minus 5 with respect to dx. And when you take here integral of 5 minus x is 5x minus x square upon 2, where the limits are from 1 to 4. Substituting these limits will give us the final answer, and on substituting these limits you will be getting here 5 into 4 20 minus 4 square 16 upon 2. Next minus you have 5 into 1 5 minus 1 square upon 2 minus 1 by 2. And when you solve this, here you get 20 minus 16 upon 2, that is 8. This gives you the value equal to 12, and here 5 minus 1 by 2 gives you 9 by 2. 12 minus 9 by 2 gives you the value equal to 15 upon 2. So, here we get 15 upon 2 as the required answer for this question. So, value of this integral will be given by 15 upon 2. For answering this question correct, you are going to get complete 1 mark. So, I hope this question is clear to you. Now, let's move on to our next question. So, in question number 20, you can clearly see we have been provided with 2 choices, and both the choices are from the same chapter, application of derivatives. In the first choice, it has been stated if f of x is equal to x raised to the power 4 minus 10, then find the approximate value of f of 2.1. And the second choice, it has been stated, find the slope of the tangent to this given curve, which is y equal to 2 sine square 3x at x equal to pi by 6. So let's proceed with the first choice. In the first choice, you are asked about the approximate value. So which is need to be obtained at f of 2.1. We need approximate value of this, and you know that f of x plus delta x is equal to y plus delta y. Taking that case into consideration, very first, we consider this given function as y. So here let y is equal to this given function, that is x raised to the power 4 minus 10. Then in this manner, you can definitely obtain the value of f of 2. So f of 2 in this case will be equal to 2 raised to the power 4 minus 10, that is 16 minus 10 equal to 6. So here this is the value of f of 2. In similar manner, here I can also obtain dy by dx. So if y is x raised to the power 4 minus 10, on taking derivative, I get here 4x cube as dy by dx. So this implies dy by dx can be obtained at x equal to 2. Why I am considering at x equal to 2? Because here we need the value of f of 2.1, that is x plus delta x, where x is 2 and delta x is 0.1. So this gives me the value 4 into 2 cube, that is 8. 4 into 8, 32. So dy by dx is obtained here, and let's consider here that delta x in this case is equal to 0.1 and x is equal to 2. Taking that case into consideration, we can definitely state that delta y upon delta x is equal to dy by dx at x equal to 2. So if that is the case, through this I can easily get the value of delta y. So delta x is already 0.1, delta y is not known, dy by dx at x equal to 2 has been obtained as 32. This implies that value of delta y will be equal to 3.2. Now the value of delta y has been obtained as 3.2. So you are aware with this value of delta y 3.2, you are aware with this value of delta x, you are aware with this value of x equal to 2. Taking all these into consideration, now we can definitely obtain the approximate value of f of 2.1, that is f of x plus delta x is equal to y plus delta y, where we know that the value of y in this case will be equal to, here the value of y in this case will be equal to 6 at x equal to 2. So we can further write here the approximate value of f of 2.1 can be obtained by considering f of x plus delta x is equal to y plus delta y, where y represents f of 2. So I get here further f of 2 plus 0.1 is equal to 6 plus 3.2. So here we have the required value of approximate value of f of 2.1 equal to 9.2. So this is the final answer for this question, where we have obtained the required approximate value equal to 9.2. And here you can see in this question related to approximation, you need to obtain the value of delta x, delta y, and with the help of that you can clearly get the approximate value. And for answering this question, you will get here complete 1 mark for this question. I hope it's clear to you. Now moving to the choice provided in the same question. In the choice provided in this question, you can clearly see we have to obtain the slope of the tangent to this given curve. And whenever we talk about slope of a tangent to the given curve, that is given by first derivative of the function. So here y is equal to twice of sine square 3x, and you need to obtain its slope at x equal to pi by 6. So firstly I will be obtaining dy by dx to get the required slope. So in this question, as y is given as twice sine square 3x, and here we need to obtain the required slope. So, slope of tangent to this curve to given curve is clearly dy by dx at x equal to pi by 6. So, I need here the first derivative of this function, and when you will be obtaining the first derivative of this function, since you have y equal to 2 sine square 3x, you need to apply here chain rule to get this derivative. So, dy by dx will be equal to twice, on taking the first derivative, here you will be getting 2 sine 3x, derivative of sine 3x is equal to cos 3x, while derivative of 3x is 3. So, you can clearly see this simplifies to the value 12 sine 3x cos 3x. So, I have dy by dx equal to 12 sine 3x into cos 3x, where I need the derivative at x equal to pi by 6. So, in the next step, I will be substituting here x as pi by 6. So, dy by dx at x equal to pi by 6. So, on substituting here, you get 12 into sine 3x is sine pi by 2. And here cos 3x is cos pi by 2. The value of cos pi by 2 is 0. So, this whole term becomes equal to 0. That means the slope is now 0. So, we get here the required answer for this question, that slope of the tangent to the given curve at x equal to pi by 6 is 0. So, here you get the required answer for this question, that slope of the tangent to given curve is 0. And for answering this correct, you will get complete 1 mark for this question. I hope it is clear to you. So, in this question, the required answer is 0. So, here we come to an end to section A. Now, let's move on to section B, which contains 6 questions of 2 marks each.